Good afternoon, my dear friends. So, today we are going to discuss the first video on module number 4, that is nanomaterials and characterization techniques. Now, syllabus is already there in the PPT presentation. Now, nanotechnology means we study the engineering things at a nanoscale, that is 10 raised to minus 9. Okay, and it is a challenging field nowadays. Now, what is the importance of nanotechnology? See, the implications of the nanotechnology are wide ranging, and it could include medicine, military applications, computing, and astronomy. It is being used already in sunscreens, self cleaning windows, stain repellent fabrics, etc. Now, I will tell you about the emergence of nanotechnology. It has led to the design, synthesis, and manipulation of particles in order to create a new opportunity for the utilization of smaller and more regular structures for various applications. See, nowadays in various fields, this nanotechnology is used. In recent years, nano-sized metal oxide particles have been used in optical, electrical, magnetic, catalytic, and biomedical properties, as well as their high surface to volume ratio. So, what is the important property? High surface to volume ratio and specific affinity for the absorption of inorganic pollutants and degradation of organic pollutants in aqueous systems. Now, what is emergence of nanotechnology? It is a relatively recent development in scientific research. The development of its central concepts happened over a longer period of time. See, though it is associated with modern science, they were used by artisans as far back as 9th century for creating a glittering effect on the surface of pots. Okay, for example, pottery of Middle Ages often remains a distinct gold or copper colored metallic glitter, and this is caused by a metallic film that was applied to the transparent surfaces of glazing, which contains silver and copper nanoparticles dispersed in glassy matrix of ceramic glaze. See, basically there are two approaches as per the syllabus. One is top down approach and second one is bottom up approach. So what is top down approach? Top down approaches refers to slicing or successive cutting of bulk material. We cut the total bulk material into slices to get nano-sized particles. So this is top-down approach. They are similar and rely on either the removal or division of bulk material to produce the desired structure with appropriate properties. See, the total bulk material is divided into nano-sized particles. It is top-down approach. So what is bottom-up approach? It refers to methods where devices create themselves by self-assembly. Chemical synthesis is a good example. In bottom-up approach, atoms, molecules, and even nanoparticles themselves can be used as the building blocks for the creation of complex nanostructures. It is very easy. Bottom up approach is cheaper than top down approach, but getting control over the methods is very difficult. Economically, bottom up approach is okay more cheaper than the top down approach, but to carry out that methods practically it is difficult. Now, what are the challenges in the nanotechnology? The most immediate challenge in nanotechnology is that we need to learn more about materials and their properties at the nanoscale. See in conventional materials easily we can carry out the different experiment on the material and we can study the properties, their uses, etc. But nanomaterials are not so easy to study. That means we cannot easily identify the properties of nanomaterials. See, elements at the nanoscale behave differently than they do in their bulk form. See, suppose we take one material in the bulk form, and at that time the properties we identify are different. And when we divide that bulk material at nano level, so at nano level, okay, their behavior is different. Okay. Since they are so small, nanomaterials are so small, they could easily cross the blood brain barrier, a membrane that protects the brain from chemicals in the bloodstream. Okay, thank you, friends.